तो दोस्तों दोस्तों आज हम लोग पार्ट 3 बिटसेट के क्वेश्चंस करने वाले हैं। जिन्होंने पार्ट 1 पार्ट 2 नहीं देखा है वो हमारे चैनल पे जाके पार्ट 1 एंड पार्ट 2 भी देख सकते हैं। एंड जो बिटसेट में रियल टाइम प्रॉब्लम्स आई हैं उनको हमने देखा है कि बेसिकली किस तरह के प्रॉब्लम्स आती हैं और किस तरीके से उनको सॉल्व करना है। तो इस वीडियो में भी हम वही देखने वाले हैं। मेरा पर्पस एक्चुअली ये वीडियो बनाने का केवल और केवल दो है, दो पर्पस है बेसिकली। एक तो आपका बिटसेट का एग्ज़ाम आने वाला है जो कि कहना चाहिए काफ़ी आपका इसको देख के काफ़ी आपको जो है ना हेल्प मिलेगी। दूसरा, मेरा हमेशा स्टूडेंट्स से कहना है कि हमेशा आप रियल टाइम जो क्वेश्चंस आए हुए हैं उनको देखो और उसमें थोड़ी सी रिसर्च करो अपनी कि आप किस तरीके से उसको जो है ना किस तरीके से क्वेश्चंस आते हैं, किस तरीके से रिलेटेड क्वेश्चंस बन सकते हैं उसमें, और क्या क्या आपको बेसिकली उसके हिसाब से पढ़ना पड़ सकता है। तो ये हमारी हमेशा कोशिश रही है कि आप लोगों को जो है किसी तरीके से जो है इन सारी चीज़ों से एक्सपोज कराऊं जो कि कहना चाहिए आपकी बहुत ही हेल्प करने वाली एग्ज़ाम में, चाहे वो जेई मेंस हो चाहे वो बिटसेट हो। जेई मेंस में भी मैं आपने देखा होगा हमने इस तरह का वीडियो बनाए थे, आप हमारे चैनल पे जाके देख सकते हैं। और इसमें भी बेसिकली क्या है, तो विदाउट वेस्टिंग एनी टाइम लेट अस स्टार्ट आवर टुडेज लेक्चर। बट बिफोर स्टार्टिंग लेट मी टेल यू, प्लीज subscribe my channel, correct? Because with your subscription this gives me motivation to me, correct? So subscribe my channel so that whenever some new video is coming or new thing is coming on this channel, you should know that, and if it is helpful you please attend that, correct? So now let us start our class for today. So this is your first question on your screen, which has come in Bitset, correct? So here, let us see what is the question. Question says, the ratio of specific heat Cp upon Cv is gamma, correct? In terms of degree of freedom, N is given by. So we have to find the ratio Cp upon Cv in terms of N, and that is degrees of freedom, correct? You must have studied your chapter and how this specific heat Cv and Cp, they are connected with degrees of freedom. So let me tell you, your specific heat for constant volume, it is connected with degrees of freedom as correct. Now we know Cp minus Cv is R. So here Cp is nothing but R plus N by 2 R, or you can say n by 2 plus 1 r. करेक्ट? तो इसमें तो कोई प्रॉब्लम है नहीं आपको, करेक्ट? इसमें कोई प्रॉब्लम, कोई प्रॉब्लम. तो नाउ वी कैन फाइंड आउट गामा. गामा इज व्हाट? Gamma is nothing but Cp upon Cv. It is given in the question itself. Then what is this? This n plus 2 plus 1 n by 2 plus upon n by 2 r, and if you will solve it, this will come as correct. So here our answer is. Now let us go to the next question. Frequency of oscillation is proportional to this thing. So frequency of oscillation, you know, what is basically this angular frequency, you know, this is this formula. No. And what is frequency of oscillation? F. F is nothing but omega upon 2 pi. Because F is nothing but 1 upon T. Correct? And T is your 2 pi root m upon. These are the formula you already know. Correct? Now here, in this question you see, here the spring constant is K and here it is basically 2K. So, if you see, this is what? This is your parallel arrangement. That is clear or not? So here the equivalent constant will be 2K plus K, because equivalent constant is nothing but K1 plus, and this is basically. So naturally, what will be your this will be your root correct. So this is how you can do this, and basically this frequency now, this is your constant. The frequency is basically, if you see, proportional to root 3k by. Correct. Now let us go to the second question. An instantaneous displacement of a simple harmonic oscillator is this. Its speed will be maximum at time. Correct. So here x is given as a cos omega t plus pi by 4. Correct. So here speed is so what is the speed? Speed is nothing but dx upon dt. And what will be this? This will be basically minus a omega, of course, will come sine correct. Now when this speed will be maximum, this will be maximum when this is equal to 1 and sine is when it is 1, when your omega t plus pi by 4 must be equal to pi by sine pi by 2 is 1. Correct. So omega t is nothing but pi by 2 minus pi by 4, or it is pi by 4. So that means t is nothing but pi 4 correct. Let me tell you, in Bitsat, questions come very easy. Correct. Let us go for this. A particle executing a simple harmonic motion along y-axis has its motion described by this thing. The amplitude of simple harmonic motion is basically, if you see, what is the periodic function here? Periodic function is this. A and what is the amplitude of this? This is A. So what can be the amplitude of this? Correct. Let us go see, we will see this question. Here again, two spring, this thing K1, K2 are connected. Frequency of oscillation here, if both K1 and K2 are made 4 times their original values, frequency of them. This is the same question we have done. It is again in the parallel arrangement. So your K equivalent is nothing but K1 plus K2. Correct? So frequency is nothing but 1 upon 2 pi root K1 plus K2 upon M. Now it says K1, K2 are made 4 times their original values. So F dash is nothing but 2 pi 4 k1 plus 4 k2 upon m. Or you can say so here the answer is basically frequency will be doubled. Correct? Let us see this one. Amplitude of a damped oscillator becomes 1/3 in 2 seconds. If its amplitude after 6 seconds is 1 by n, the value of n is correct. Now, your damped oscillator, if you see what is the frequency given by, that is A, sorry, amplitude. Amplitude is given by E minus T or dt upon 2m. If you don't remember, then this is the basically mathematical. Now, when t is equal to 2 seconds, then what will be A? A is A0 by 3. It is given in the question itself. That means A0 upon 3 equal to A0 minus 2b upon 2m. Or we can write it as E b upon minus m is nothing but that is equal to 1 by 3. Correct? Now, if you put t is equal to 6 seconds, then suppose A0 is reduced by n, then that will be equal to A0 E minus, here it will become 3b by m. Or we can say 1 upon n is nothing but E minus b by m to the power 3. And that we know 1 by 3 to the power 3. So n is nothing but this is how systematically you can do this question. Correct? Let us go to the next. An organ pipe open from both ends produces 5 beats per second when vibrated with a source of 200 this thing. So organ pipe is there. Correct? This is your fundamental frequency, and if you want, then this is your second current. So in this case, basically, your F is 200 hertz. Correct? In this case, but we have to take beats. Now beats can be plus minus 5. So this can be either 25 hertz or 195 hertz. Oh, sorry, 200. Correct? In the case 2, if you see, this is your frequency is basically 2 times. This frequency is basically 2 times, and this is plus minus 10. Or F, we can write it as 210 plus minus 5. And this can be 205 hertz or 215 hertz. That means, what is the fundamental frequency here? Correct? You understood this? So here answer is now let us see another question. Let's go through this question. A whistle of frequency, this thing is sounded on a car traveling towards a cliff with velocity of 18 meter normal to the cliff. If C is this thing, then the apparent frequency of the echo as heard by the car driver is the other. Now here, if you see car is what? It is producing, car is basically a source. And this cliff is observer. They are approaching. Correct? Now, in this case, basically, with the Doppler effect, what is the frequency becomes? Frequency will increase because they are approaching. That means V plus V0 upon V minus Vs. Correct? Here, observer velocity is basically 0. Source is moving towards the observer. Correct? So what will be the frequency? Frequency is 1000 hertz, and here 330 upon 330 minus 18. This has to be more than 1000 hertz. So instead of, if you see all other options are less than, so this has to be the answer. Such type of questions you may not do also calculation part, because since source is approaching to the observer, the frequency has to increase. Two trains are moving this thing relative to each other, towards each other. Here, source and observer, they are moving with towards each other. So here again, frequency is nothing but V plus sorry, this is source and this is observer. So here, if you see 600, 340 plus 15 upon 340 minus 20. If you calculate this, this will come around 600. So this is your answer. Then the fundamental frequency of an open organ pipe is 300 hertz. The first overtone of this pipe has same frequency as first overtone of a closed organ pipe. If speed of the sound is 330 meter per second, then length of the organ pipe is correct. So here, if you see, for an open pipe is nothing but N1 is what? It is the fundamental frequency. So L, if we add all the things we know, 2 into 300 hertz is the fundamental. That means L is basically 11 upon 20. Correct. Now first overtone is what? Is basically n2, and that is equal to 2n1, and that is equal to 2v upon 2l. Correct? Now this is the first overtone of open pipe, and first overtone of closed pipe. First overtone of closed pipe is nothing but your this thing that is n3, and that is 3 and 1, and that is 3 v upon 4 l dash. L dash is the closed pipe. L dash is what? We can assume L dash is the length of the closed pipe. Now in this case, it is given that first overtone of open pipe is equal to frequency of the first overtone of closed pipe. That means 2 V upon 2L is given as 3 V upon 4 L dash. That means L dash is nothing but 3 L by 4. Or we can say 3 by 4 into 11 by 20. This will come around 41.25. Of course, you have to in centimeter. Correct? Because here meter per second, so it will come in meter, but in centimeter it will be like this. Correct? Now, there are 3 charges. Here, suppose this is Q. Length is L. And here L by 2, L by 2. Correct? In order to make the net force on Q 0, the charge Q must be equal. Correct? So let us make the charges due to 4Q. It will be like this. Suppose this is F 4Q, and due to Q, this will be again like this, F Q, and this charge has to be, sum of this charge has to be, that means K Q into 4Q upon L square plus K Q upon L by 2. This must be equal to 0. Correct? So what will come here? It will come as 4q square plus 4q is 0, or we can write it as q is minus q. Correct? Simple question. Electrostatics. Q is minus q. That is okay. Let us go to the next question. A charge plus q is at a distance L by 2 above a square of side L, then what is the flux linked with the surface? Now, suppose you have a here L by 2, charge q is there, then we can do, we can complete this square. It will become a cube. Now in this cube, whose length is obviously L, 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 correct? So by geometry of this, q is there at the center of this cube. So through the cube, flux will be q upon epsilon 0. So flux through the side. Now how many sides are there? There are 6 sides are there. That means it is divided by 6. Correct? Simple question. Now, in this case, let us see what is this question first. Which one of the following graphs represent the variation of electric field with distance r from the center of the charge radius r? Now it's a spherical conductor. You know, all the charge, the complete charge will be on the surface of the spherical conductor. Correct? So in the spherical conductor, we know that inside there is no charge. All the charge are on the surface. Since there is no charge, then inside this, your electric field will be 0. Correct? And from the surface, it will be start as K Q upon R square term means E is proportional to 1 by R square. Correct? 1 by R square. So what will you do? First of all, from 0 to R, electric field is 0. So this is the only figure where from 0 to R, we have electric field as 0. And after that, it is decreasing because E is proportional 1 by R square, inversely proportional. It's rapidly decreasing, basically. Correct? Let us see what this question says. Charge Q is distributed to two different metallic spheres having radii x and 2x, such that both spheres have equal charge. Then charge on the large sphere is sigma. Correct. We have one sphere as x and another sphere as 2x. Suppose we have charge as q and we have charge as q dash. So what is the charge density here? Q upon 4 pi x square. And what is the charge density here? Q dash upon 4 pi 2x square. Or we can say Q dash upon 16 pi x square. Correct? In the question, it is given that sigma is nothing but sigma dash. That means Q upon 4 pi x square is nothing but Q dash upon 16 pi x square. Or we can say Q dash is nothing but 4Q. Correct? Now it says charge Q is distributed to two different metallic spheres having this symbol. That means one is having, if we say total charge is basically what? Total charge is Q, or 5Q is nothing but Q, or Q is nothing but Q by 5. Then larger sphere is Q dash. Q dash is nothing but, this will be 4Q upon 5. Correct? So on the larger sphere, it will be correct. In a given circuit below, the charge in microcoulomb on the capacitor 5 microfarad is now if you see 6-volt battery is there, so here it will be 6 volt and here also it will be 6 volt, correct? E now these two are in parallel, so we can write equivalent, that is 5 plus 2, that is 7 microfarad here, and this is 3 microfarad. And what is the difference between these two? 6 volt. Correct? Now here, what will be the charge, or we can, what is the equivalent now? Equivalent of this? This will be C equivalent 3 into 7 upon 3 plus 7, or 2.1 microfarad. So what is the Q? Q is nothing but 2.1 into 6. This is microcoulomb. Correct? Now, this is the charge 2.1 into 6 coulomb. It will be in this orb, you can say, correct? So, just see what is the potential of this. What is the potential of 3 micro? Here, potential of 3 across 3 microfarad is nothing but your charge is what? Charge is basically, if you calculate this, this will get 12.6. So 12.6 upon 3, that is 4.2 volt. And what is the potential across 7 microfarad? That is 6 minus 4.2, and that is 1.8 volt. Now, this arm, we know this is 5 microfarad and this is 2, so 2 microfarad. Potential difference between these 2 points is 1.8 volt. Then what will be the charge here? Charge, we have to find out the charge. Charge across 5 microfarad. It is what is, this will be nothing but C into V, that is 5 microfarad into 1.8 volt, and that is basically 9 microcoulomb, and that is I hope you understood this question very well. Very simple question of capacitor problem. So in the beginning, I told you that your Bitsat questions are easy. You can solve each and every problem, provided you know how to solve. You must remember all your formula, first of all. All questions are formula based. It is not JEE Mains or JEE Advanced. Remember all your formulas. Then the next important thing is speed. If you have a proper speed, then you can beat this exam. There is no doubt about it. Still, there is a time. These type of questions only are going to be asked. Correct? In the next lecture, again I will come with the problems which have come in the Bitsat exam. Now, as you have seen, electricity has started, though electricity, magnetism, and then all other chapters will be there. So please keep yourself connected with my channel. Subscribe my channel. I am on an average every day I am taking a live class solving these Bitsat real-time questions. So please subscribe my channel, and tomorrow we will again meet in this live class. Thank you very much.